All right, we've got something really special for you today. Thanks to some leaked engineering notes, we get to pull back the curtain and see how a really sophisticated AI, Claude, actually thinks. We're going to peek inside the incredible fortress it has to build just to remember what you said 5 minutes ago. Let's dive in.
So you've probably wondered this yourself, right? You're deep in a chat, you're throwing documents at it, asking all these follow-up questions. How in the world does it keep it all straight? You'd think it just remembers, but the real answer is way more interesting. The truth is, it doesn't, not automatically. For an AI, remembering is a constant, desperate fight. It's in a battle against a fundamental limit of its own design. And that limit is called the context window. Now, the easiest way to think about it is like a whiteboard. Every single thing you say, every tool it uses, it all gets written down on this board. But, the whiteboard is only so big. And when it's totally full, to write down the new stuff, it has to erase the old stuff. The AI literally starts forgetting the beginning of your conversation.
So how do you get around that? That's a huge problem. Well, these leaked notes show an absolutely brilliant solution. A whole system of defenses, stacked on top of each other. It's so intricate, we're calling it the memory fortress, and its only job is to protect that precious whiteboard space.
So here's our plan for storming the fortress. We'll start with the main problem, then we'll check out its outer defenses, move on to its really clever tricks and illusions, and then see its final, last-ditch effort, the AI summarizer. And at the end, we'll boil it all down to the core design principles that you can learn from.
Okay, first stop. We need to get our heads around the basic philosophy of this thing. It all comes back to that memory limit, that context window wall it's always about to run into. And right away, you can see the genius of this strategy. It's not just one big solution, it's a whole cascade of them. The system is designed to always try the fastest, easiest, and computationally cheapest fix first. And only if that doesn't work does it escalate to the next layer, which is a bit more powerful and a bit more expensive. It's just a masterclass in being efficient.
All right, let's head to the outer walls. These are the frontline soldiers, the simplest defenses designed to stop the most common attacks on the AI's memory.
So picture this. You ask the AI to do something, maybe search the web or scan a PDF you just uploaded. That tool could come back with a fire hose of information, right? A whole novel's worth of text that threatens to just completely flood the context window in one shot. So what do?
Well, you put a bouncer at the door, right? And that's layer 1. It's a really simple but really strict budgeting system. There's a total allowance of 200,000 characters for everything in one go. And no single tool can use more than 50,000 of that. Anything that goes over that limit, it gets archived to disk where the AI can look at it later if it needs to. The flood is stopped before it even gets inside.
Okay, now this is where things get really clever. That gatekeeper doesn't just block things, it sorts them. New stuff is fresh, and it has to fit the budget. Must reapply is stuff it's seen before, so it can be reused for free. But, and this is the genius part, there's frozen. This is data the AI has decided is really important. The system will never touch or replace this stuff. It protects it at all costs.
And this idea is so critical to how modern AI works that it's spelled out right here in the engineer's notes. It says, prompt cache stability is prioritized over spatial efficiency.
So, what does that actually mean? It means making an AI reprocess the same information over and over is incredibly slow and expensive. That frozen category protects what the AI has already figured out. The system would much rather waste a little bit of that precious whiteboard space than force a super costly recalculation.
But what if that budget system just isn't enough? What if things are still too tight? Well, the system escalates to layer 2, the janitor. And this is basically the brute force method. It just goes to the very top of the conversation and snip, it deletes the oldest messages. Simple, fast, maybe not so elegant, but it gets the job done.
So just chopping things off the top is a bit of a blunt instrument. As we go deeper into this fortress, the defenses get way more sophisticated. We're going to jump ahead a bit past some intermediate steps to the really clever stuff. The layers that are basically works of illusion.
And this brings us to layer 4, which the notes call context collapse. Now this is a much more elegant solution. Instead of just deleting old messages like the janitor did, it creates a kind of, a magic map. It's a summarized version of the conversation that only the AI can see. And this right here, this is the big aha moment. On the left is your screen. You see the complete, full chat history. You can scroll all the way back to the beginning. But on the right, that's what the AI sees. A whole chunk of the older messages has been collapsed into a short summary, freeing up a ton of space on its whiteboard. It's this brilliant illusion that keeps the full history for you,
but saves a ton of memory for the AI.
But, even this super clever magic map has its limits. When that context window is really, truly about to burst, that's when the system unleashes its most powerful, most expensive, and honestly, most mind-bending defense of all.
Get ready to meet the Royal Librarian. When all else fails, Layer 5, called Auto Compact, kicks in. And this is kind of wild. The system actually pauses the conversation and calls a second, completely separate AI. And that AI's only job is to read the entire conversation and write a new, shorter summary. The AI is literally calling for help to summarize itself, to save itself.
Now, as you can probably imagine, calling a whole other AI to read and summarize is incredibly expensive. To give you a sense of the sheer scale we're talking about here, just look at this number, 38 billion?
So what on earth is that? 38 billion. That's the number of tokens, you can think of them as words or pieces of words, that this one system saves from being wasted every single day. And it's all because of one super clever optimization that lets those two AIs share what they've learned. It just goes to show how critical being efficient is when you're working at this kind of massive scale.
So we've stormed the fortress, right? We've seen everything from the simple gatekeeper to an AI that summarizes itself. But what's the big lesson here? What are the core principles, the military doctrine that makes this whole thing work?
Okay, here are the key takeaways. First, defense in depth. Always start with a cheap and easy fix, and only escalate when you have to. Second, prioritize cache stability. Remember, it's way better to waste a little space than to waste a lot of processing time making the AI relearn. Third, the dual view. What your user sees and what the AI sees under the hood don't have to be the same thing. Fourth, use circuit breakers. If something keeps failing, just stop it. Don't let it waste resources. And finally, recover intelligently. After a huge operation like a summary, you have to carefully put the most important info back in so the AI doesn't lose the plot.
And just think about this for a second. This entire incredible multi-layered fortress, it was all built just to manage memory for a single conversation. It really leaves you with a huge question. If this is what it takes to handle short-term memory today, what kind of insane systems are we going to have to build when these AIs need to remember things not for minutes, but for years?